Okay, weekly contest 362, doing it as a virtual contest because I was asleep during the actual. Let's see if I can solve all these questions. Let's go. Virtual. I'd like to. Okay. Points that intersect with cars. That seems easy. String transformation doesn't seem super difficult for the hardest problem, but I really know absolutely nothing about what that is. That just seems like the name of an easy or medium problem based on absolutely nothing. Okay, representing the coordinates of the cars. Integer points in the line that are covered with any part of a car. At least one car. Therefore, the answer would be 7. Okay. I'm going to do this a really dumb way, just because I can. Where I'm going to say, so points equals, like the faster way to do this would be some sort of merge intervals, and that would be best in terms of time complexity. But the constraints mean this clearly doesn't matter. So I'm going to do it this way. I'm just going to hit every point from every car. And I know based on the constraints that this should pass. So then I'm just going to do nums.each, do num. So AB equals num. And points.add n. So basically what this is doing is it's going through each of these. So for 3, 6, it's going to go through 3, 4, 5, 6 and add each of those to my set. So my set now has 3, 4, 5, 6. I also add 1 and 2, and I add 3, 4, and 5, which doesn't change anything. I add 4 and 5 and 6, which doesn't change anything, and I add 7. And then it should just be points.size. That is the brute force way of doing it. But LeetCode contests, come on, man. LeetCode contests seem designed so that the first easy question you can do with brute force. These are both 7. That's interesting. This wouldn't always return 7, though. Dun, 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 dun. Hey! Okay. The proper way to do this would be to merge the intervals and then find the distance in each interval plus 1. But merge intervals takes longer to write, so I'm not going to. Determine if cell is reachable at a given time. Okay. After exactly t seconds. Ooh, okay. So, okay, wait. This is exactly t seconds, which is an edge case just if t is 1. So, return false if t equals 1 and sx equals fx and sy equals fy. Okay, and the reason that this is the case is because you can always use up extra seconds. Instead of going right 1, I can go diagonal and then down, right? Sorry, this is mirrored. Is this mirrored? Would it be right and then diagonal and right? Regardless, instead of going to the side, I can go diagonal up and then down in the same direction to use that for 2. And I can do anything like that. So I can obviously go like this and this to waste an even number of moves. So if it's possible to do in fewer than t moves, it's also possible to do in t moves. The one exception is if t equals exactly 1 and the starting points are equal. Right. Because if t is more than 1, I can reduce it to 1 or whatever, and effectively even make it 0. But if it's exactly 1, that would be a real edge case. Otherwise, I basically just want to say, since I can move both x, I can move x and or y on every move. Each of them I can move up to 1. So I just want to say, is the x distance within t and is the y distance within t? This is false because it's 1, 2, 3, 4. Haha. So this is just going to be sx minus fx dot abs less than or equal to t, and sy minus fy less than or equal to t. Oh, dot abs less than or equal to t. And I believe that is it. Should be true than false. Yeah. Right? Is it really that easy? I think it's really that easy. Yeah. They must have this edge case, though, so I'm glad I caught that edge case instead of getting a 5-minute penalty. Ooh, okay. Graph theory, that's harder. Oh, no. It's exactly 3 by 3. 9 stones, multiple stones in a single cell. One move, I can move a single stone from its current cell to any other cell. Turn the minimum number of moves required to place 1 stone in each cell. Okay, so here it's this is 3 moves. 1, 2, 3. Okay. Yeah, this is harder. Okay. 1, 2, 3, 4. This shouldn't be difficult, though, right? So anything that's 1, I ignore. The total is 9 stones, right? Can't move diagonally. Let me think about how to do this. So it seems like my method here is I figure out, I can find the cells that have more than 1 stone. I can find the cells that have 0 stones, and I can basically just test all the possibilities. Right, I'm not sure I even need to memorize here, because there would be... I feel like I can just brute force this. The key is then figuring out how to do that, but... Right? So... stones equals array, and no stones equals array. So grid dot each. Oh, that doesn't work. Grid dot each do row. Row dot each do call. If grid row call equals 0, then no stones shovel in row call. Else if grid row call greater than 1, then extra stones shovel in row call. I'm just going to set this apart a little bit. Grid row call -1. Okay. So now I will have, what is 8 factorial? 8 factorial is like 30,000. Yes, that's fine. So I can literally just try every possibility. Okay. So now I have so first I should define all possible orders of no stones. So I'm going to do no stone. So I'm going to do possibilities equals no stones dot permutation no stones dot length. I want to make sure this is working. So I'm then going to and have it return a number so it won't error out. So this should just be array into integer. Okay, where's the problem? Line 6. Oh my god, that's so true. Better way to do it. Because I care about the indices more than the value. What? And did I not close my parenthesis somewhere? Okay, yeah. I can't type. Doesn't reflect very much on my programming ability. Maybe a little, but not very much. Okay. So, right, so I need to do this 2A. So this is 0, 2. Whereas there are 2, 1, 2, 1, 2, 1, 1, 2. Okay, so there are 4 things that are empty. So this should have 24 possibilities. See if this is 124. Great. So this is working. Okay. So then I'm going to do possibilities.map. Possibility. This anymore. And I'm going to say, what do I want to call my helper function? Num moves of possibility and also extra stones. Okay, so basically I'm going to have these go in order, saying, oh, well, you're going to take from the first extra stones until it's empty, because they should be exactly equal. Oh, and then I'm going to do possibilities.min to return. Okay, so this takes in a possibility and extra stones. Okay. I'm going to say total equals 0. This is going to look at every possible combination because the order of the possibility changes, but each time I'm going to have it go through the extra things first in order. It's definitely redundant, but it's not disastrous because 8 factorial, the worst case, is only like 30,000 possibilities. Is only like 30,000 or 40,000, whatever. It's less than 100,000, easily passing. Okay, so possibility dot each do pose ij equals pose. And let's say cur equals extra stones dot shift. Would also work, but I like doing shift. Let's call this A, B, N. Okay. So if N greater than 0, I'm going to say N minus equals 1, total plus equals A minus I dot abs plus B minus J dot abs. So what this is doing is it's saying, here's a space with extra stones. I'm going to take one of those extra stones and move it to this position. So that's going to be the X difference plus the Y difference. However, if N equals 0, then I'm going to say actually just not make this an if statement at all, couldn't I? Because I want to do this either way. So if N equals 0. I definitely want to do that regardless. And I just want to return total. Yep, so I'm going through trustability. I'm taking the extra stones from the piles in whatever order I created them, because it doesn't matter. I'm trying each combination. That's why I'm doing all the different orders with permutations. One of them will be minimal, or more than one will be minimal. That's probably the case, because I can use each pile. If it has 3 stones in it, I could do this one and then this one, or this one and then this one. Same combination. I could deal with that, but I don't have to, based on the constraints. Okay. So I find this position. I can have this position. If N equals 0. Okay. It's possible the if logic won't work, but I should catch that on the example test cases. Eventually, this gets me the total distance, and then I take whichever of those is lowest. What? What does extra stones look like? Wait. I like having the return separate. P extra stones. So extra stones is fine. What? How is N nil? So is this the issue? No, it's not. Are these not matching up somehow? Option 1. And here I have 4. That's correct. I don't use N for anything else here. Oh my god, I need a do bit. Because that's an actual array. Right. Because I'm using the same array each time, it's the same array in memory. I get 3 and then 4. Bada bing, bada boom. Am I printing anything still? Or did I take out all my print statements? Great. So this should work. shouldn't run afoul of max time. There we go. Okay, yeah, again, this is why you test run your code. Let's see how I'm doing on time and the people who are already finished, so I can feel bad about myself, even though I'm actually fairly good at this. Modestly. Okay, you finished in 11 minutes. That is really impressive. I'm already 10 minutes past you. 9 minutes past you. And I haven't done the hardest question. Okay. Still, this seems like a not difficult question from the very generic name. Let's see if that holds up. So I have two strings of equal length. Following operation. Remove a suffix of s. Oh, of length L. Okay. Integer K. Oh boy. Whoa. Okay. I see the issue. So here, right. Less than L, or greater than 0, but less than N. So it can't be empty. It has to be whole, but it could be any number. Oh boy. Okay. Okay. I can do this. Here it's only one up. Right. Got it. So basically, I'm going to pseudocode a bit here. Even though I haven't done that here, I think it's helpful here. So, okay. So length of len, k operations, 1 to n in an operation. Find how many combos equal k can be 10 to the 15? Jeez. That's just rude. That makes it so much harder. Find how many combos in K are equal to if length. Like this is how many you'd need to do it in one. Mod len. Mod n. I'm already calling it n there. Okay, this is going to be super mathematical. It's going 10 to the 15, so I can't possibly test every k. That means it's going to have a repeating pattern. That means to me, given that this is a contest and not an interview, the fastest way is probably to test different combinations. So I'm going to use the example test cases. Oh, man, the repetition is so irritating. I'm going to ignore repetition for now. I'm sure that makes it a harder question. What if I make this 3 and 4? 1 should just be 1. And 5. Okay. Oh my god. I didn't actually write a function. Okay, I'm going to do this with pencil and paper. So, oh boy. Okay. be dumb sometimes. So if I have this one, and I get 1. Here, I get 2. Here, if it's 3, so I can add, I need to get to 2 mod 4. I can add 1, 2, or 3 each time. So I could do 1, 2, 3. I could do 3, 2, 1, 2, 2, 2. I can't get to exactly 2, but I could get to, I can get to 6. Can I get to 10? I can't get to 10 either. So here there are actually just 3 possibilities. But if I do this to 4, then I need to get to 2 after 4 operations. That could be 1, 1, 1, 3, 1, 1, 3, 1. Oh my god, no, there were more in the other one. There are 6 ways I can rearrange this. That's going to be 1, 3, 2, 3, 1, 2, 2, 1, 3, 2, 1, 2, 2, 2. That's 7. But what I want to do, I want to write a modulo version of this. So I think I need to first write the DP version. Then I try things out and see a pattern. Then I figure out what to do with K. Oh boy. Okay. DP version is going to be easy to write. So n equals s dot length. Memo equals array.new. And I can do this up to k times, but k could be bigger than n. So I'm actually going to have it be n times. And here I have an object. Memo. Diff len equals. I can't even try all of these. That's so irritating. Okay, I'm going to ignore repetitions for now. Okay, again, I'm going to ignore time complexity for now. Work on that later. So, if len equals 0 until s equals t, s equals s -1 plus s from 0 to -1. And diff len plus equals 1. Okay. Why not? Because why pass in variables when you can just make them class variables accessible each time? So now I'm going to do num ways starting at so right now I'm starting at 0 and k is also 0. So this is going to be the total change so far, mod n, and this is going to be k. So return if the change matches to diff len, then I return 1, otherwise I return 0 if k equals 0. return memo of change k if memo change k. Now here's my main logic. So now I'm going to do, for every number less than between 1 and n, options equals empty array 1 to n dot each do I, options shovel in is just going to be num ways of change plus I on n minus 1. Now I'm going to have memo of change k equals options.sum. Does this work, first of all? Oh yeah, I never defined n, huh? Now it'll work. 0, 1, that's not good. Okay, that one's fine. Why is that 1? That shouldn't be 1. Okay, so ignoring time optimization completely, why doesn't this work for the test cases? I start with my change, I'm adding I to it. Obviously, that's not what makes a difference here. Okay. Right, so that one's 2. That one's should actually be 2 or 4, but that's fine. Okay. So if k is 0, right, then the change should equal the diff length if it's valid, otherwise it is not valid. That seems right. Memo part should be fine. Div is definitely fine. Yeah, S and T don't actually matter. Right, because if it's a string of length 6, I can change it 2 times or I can change it 8 times. So change equals diff len. Oh my god. Num weighs 0 instead of k. Well, I deserved that one. So the second one's going to be wrong. Didn't even hit this bad code. Love it. Second one's wrong, but it's wrong for the right reason. It's wrong because I haven't handled that case yet. So that's fine. So make that 1, 3, 4, make this 5. What's my pattern? Oh boy. That is not an obvious pattern at all. Huh. Plus 1, plus 5, plus 13, plus 41. Times 3 minus 1, times 3 plus 1, times 3 minus 1, times 3 plus 1. Is that just a coincidence, or does that actually work? Oh. Yep. Times 3 minus 1, times 3 plus 1. Interesting. 3 being the number of shifts I can do. Zero. 3 plus 1 times 3 minus 1 times 3 plus 1 times 3 minus 1. Okay, so what if I made these longer? What if this was... That is not at all what I meant to do. I meant to do find and replace E, 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 E. So now it should be times 4 plus 1 times 4 minus 1. That's my theory. Times 4 minus 1 times 4 plus 1 times 4 minus 1. Okay. Great. So I still need to figure out how to do this efficiently. Okay, so I'm going to keep ignoring the repeat case for now. I want to at least get an answer on the non-repeat case. So this is just for experimenting, because I'm going to do it more efficiently the other way. Although I probably should test if they actually match up too, because that could make a difference. Nope, Those are special cases. I'm going to totally ignore them for now. So right now, numways is just going to be total equals 0, n equals s dot length, k times, from 1 to k, by each I divided by 2 equals 1, then it would be, I'm going to split this up. If I divide by 2 equals 1, then total equals total times n plus 1, else total equals total times n minus 1. Yep. For my example test cases, this should get exactly the same thing. Started that off differently. Here we go. Oh boy. Okay, what did I do wrong here? Zero to k. Is that what I want? But that should be the same thing. It's n minus 1. There we go. And just to check, is that what I had copied? Yes, it is. Thought so. Okay. Boom. Now, how do I do this more efficiently? It's not quite a power. Right, it's times n squared minus total for every 2. That doesn't work. Wait. So I have tn plus 1 times n minus 1 equals tn squared plus n minus 1. I can't even go to 10 to the 9, though. I have to make it repeat less than every 10 to the 9. some ways I'm going to say equals 1 while true, key number of ways A, B, C, D, E, and this is C, E, A, B, I plus equals 1. This will be fun. Oh boy. Really need to make sure to go back and change these in a minute, but this should just print out wrong number of arguments. What? How? I don't actually care about that because I'm customizing it. Okay. This seems dumb, but I want to check if there's any repetition. Okay. Fine. We'll do this the slow way. Let's do it this way. Res equals set. Dot add. So this is just checking for repeats. So pi res dot size. I'm just going to make this a little more readable. I'm going to check, does this get to a point where it starts regularly repeating anywhere, or no? Oof. Not promising. Oh my god. So I have a way to find it, but it's too slow. That's frustrating. Shoot. So totally ignoring the edge case where it either starts with the same thing or there are multiple points. Multiple points, I imagine you could handle by just adding all of those together, by just checking each point. But the edge case where it starts there, I imagine I could test and figure that out too. But I can't handle the main case efficiently. How can k be so dang big? 10 to the 15? That's crazy. No kidding on the modulo, geez. Just to test it. No, because I know it doesn't work. Let's test it this way. This is going to be too slow now. TLE, and that was like 10 to the 11 or something. I wasn't counting carefully, but it's less than 10 to the 15. Yeah, 11. Yeah. How do I deal with k being so big? So eventually, okay, is there a different way I can see this sequence other than times 4 plus 1 times 4 minus 1? That's 4, 16, 64, 16 minus 3. 64 minus 13. Oh my god. So it's minus the last possibility. The previous sequence, rather. Right, because none of those work. Okay. So total plus equals pow of k. Sorry, it's n to the k, and it's mod 1, 2, 3, 4, 5, 6, 7, 8. Okay. So this is just going to get powers of 4. What? N dot pow. It's probably n dot pow. Ruby being Ruby. Yeah, okay. Great. So now I just need to find Okay, so geometric sequence. So I have 1, -4, 16, -64. Really, the sequence is so -1/4 from that number. So it's going to be -1/4 plus 1/16 minus 1/64 plus 1/256. Okay. This is going to be, okay. So -1/4 plus 1/16 is -3/16 times, so plus 1/16 plus 1/16. I believe this would be times 16/15. So I think this is just minus -1/5 rounded down. So total minus equals total over 5. Does that work? Booyah! This is offset by 1 though. So I actually want k minus 1. Wait, did that change it? Four eight eight four 11866. Yeah, totally different. Totally different. Heck yes. Okay, this is great. I knew the mathematical solution would win the day. So, 30 minutes. I can totally do this. Okay. Yeah, this is an interesting pattern because it's multiplying by 1 minus the number of strings, because if anything I had that didn't work in the last round will work in this round. Okay. So what that means is if it starts with 0, then I would just start k minus 2. Okay. So I'm going to say k minus equals 1 if s equals t. And now this is going to fail in the original test cases because that first one I only have one thing. What? First argument cannot be negative. Return zero if k equals 0. Does that fix it? No, it does not. Okay, I'm going to ignore the 0 case for now still. I can't ignore the 0 case, though. K has to be at least 1, right? So K minus equals 1. K minus equals 1 if S equals T. Return 1 if K less than 0. That should work, except it's going to give... No, why is that 3? I had this working. Oh my god. That's not over 5, that's over n plus 1. Okay, now that works. No. Around this. Okay, that's going to cause a problem. By sealing it. Come on, man. Here I'm just playing around with code in a way that's not super helpful. Okay, does that make any sense to do, though? Honestly, it probably does. But let me try with some more examples. E 1, 2, 3, 4, 5, 6, 7. Yep. Okay, and now when this gets 0, like it should, zero of k less than 0, 2, 0, great. Okay. back to example test cases. So now I just need to figure out God, what's the O of n way to figure this out? Or what's the not n squared way to figure out okay, so this is numways. And S and T don't actually matter. Yes, they do. STK. I need to find all the points where they're equal, basically. Okay. That's all length of time to do s equals s 1 plus s dot chop numways stk if s equals t. 0. This is going to be too slow, though. I believe this will work. Oh boy, that didn't work at all. I'm going to ignore that entirely. Yes. I'm also going to need to do it here one time, but Then I don't need t and k at all. Yes, I do. I need n, actually. Yeah. So, weighs n k minus 1 if s equals t. Okay. S equals s dot unshift s dot pop. Okay. This is going to be too slow, though. It's going to fail on it. It's going to TLE on a huge... No, why? Oh, God. Okay. I'm going to try just hard coding this one in. Turn 1 minus k mod 2 if s equals t and s equals 2. First, I want to try seeing this is a minor case. Should get 1. Yep. Now I'm going to pass the same case, but where they're different. Dang it. Two, 3, 4, 5, 6. That's just going to be 6 to the 5. Okay. Turn n to k if s dot unique dot length equals 1. Or hard coding. Yeah, you're right. Also, length isn't a word spelled that way. Okay. Hard coding in because I'm trying to figure out what's working and what's not working. That's not good. What? Oh, yep. Fair. Okay, and now, come on, at least let me TLE. Why? So I'm neglecting half the cases here, right? I want to take a break and see how badly I'm ranking right now. 8 points? Jesus. I'm in the top 100. That's ridiculous. Okay. That's good to know. I really should have done. If only this were at a better time, I could have done this contest. And I feel like I'm really getting close, too. Okay, so this isn't a great workaround. But I want to get to the point where my code is at least TLEing. Why doesn't this work? Fei, so that's going to be 3. Yeah, okay, this is a bad fix, though. Because that doesn't fix either fundamental problem. I'm missing cases this way when it repeats. Oh my god, if there are any repetitions at all, that means that literally anything would work. Why am I failing on that stupid one? That's no good. Dang it, that doesn't work. That should be 1. Yeah, that doesn't work as repetitions. Okay. If repetitions S if there are repetitions, then literally any case will work. So then it's just going to be n to the power of k plus 1. Return 0 if k equals -1 and s not equal to t. Okay. Prime factors of a number in Ruby. There's got to be a method for this. Is there not? Fine. Write my own method. Okay. S length. And I can actually check everything because, okay. And S length, is equals to n dot each. What do I have? I might be able to make this. Factors I if n divided by I equals 0 and I let's see if this works. Maybe that's built in, or maybe I have to require it. I have to require it. Fine. Move it here to my actual code. Perfect. So now I'm just going to do factors.any I. I'm going to say s equals I times s from 0 to n over I. String can be coerced into an integer. Like this. Amazing. 5. Oh, God. K is 1, though. That one. Oh, come on. Does K have to be at least 1? K does have to be at least 1, so this is meaningless. How the heck am I getting 5? Shoot. Dang it. I have to see if that fixes the other things. Why is Fei Fei double what it should be? Okay. Dang it. Okay. I got whatever. I got really, really close on this one. I can do this works fine for the basic case where there are no repetitions. Small issue there. I don't know what it is. This works fine for the case where there are no repetitions, but it is but it's actually at the starting point. Sorry, they start equal. And this repetitions logic is failing me somewhat. So I don't quite have the repetitions case, And I don't totally have this special case either, because actually it could be if s not equal t, then this is going to be turn k over 2 if s unequal t and s dot length equals 2. That part I think is fine. What's my final rank? Do I stay in the top 100? No, of course not. I'm curious though, how would I actually end up doing since I took the whole time? Okay, I would have ranked number. No, I took a little longer than that. I took what, like 21 minutes, something like that. I would have ranked in the top 250 though. That's not bad. I don't yet have the repetition logic down. The repetition logic really is a problem for me, because I think ultimately it does matter how many repetitions there are. Right. It can't just end in any spot. I need to check at each spot, is that a repetition? Okay. Okie doke. I can figure this out. I'm going to do it later. I'll post my solution for it. But basically, I just need to fix this. So instead of determining just Boolean, is repetition true or false? Right now, my logic is based on the assumption that it could end anywhere, i.e. every character is the same, is what it's implicitly doing. What I actually want to find is how many of the ending places are valid, and instead of multiplying by so what I'm basically going to want to do is into the k times, and then this is going to be the num reps, basically. So rather than return a Boolean, I need to return the actual number of repetitions. Once I do that, then this is just going to be all the different spaces that the repetitions can go, with special logic if k equals 1 that I can handle, because that's the only special case. But for example, if there are 3 different ways to do it, then I'd multiply by 3 because it could end at any of those 3. Does that fix it? Okay. It's a little complicated. I don't yet have all the details down, but I will figure it out. This repetitions part is the last part giving me trouble. I figured it out for the general case. I figured it out for the case where they're all the same. The repetitions I've more or less divided in adequate time. That's what I'm still working on. Hope this was interesting and helpful. And hopefully I'll have a proper solution to this posted soon when I post the video.